Hello, a warm greeting to everyone those who are watching this video. This video is powered by Team GOC Trichy. This video is regarding the trimming procedure for fabricated bogie frame used in WDP4 and WDG4. Here we have shown all the tools required for locating the pop marks. These are the reference drawings that we have used. This is our drawing number 510. In the next drawing, we have shown all the distances that we need to check. After this, the application of chalk powder. Here we are applying the chalk powder on the longitudinal beams, upper plate, side plate, as well as on all the 6 vertical damper brackets. Here we are applying on both the sides. This is left side, that is top plate of the longitudinal beam. On the side plate also. In the same manner, we have to apply the chalk powder on all the places. Now in the drawing, we are showing all the center points of the bracket already punched by the manufacturer. Point number 1, 2, 3 on the right side, and these are point number 4, 5 and 6 on the left side, and this 6 points forms the 3 axis. Now in the bogie frame, first we go towards the right side. So this is the center point of the bracket number 1 that we have marked in the drawing. This is the center point of bracket number 2. It is already punched. Here with the help of chalk powder we are showing. This is a point number 3, center point number 3. Similarly on the left side, this is point number 6. This is point number 5, and this is a point number 4. This is all for center points forming the 3 axis. For easing the Trammeling procedure, we are naming the pop marks in alphabetical order like A, B, C, D, E, F. So now locating the pop marks A and C. For that we will move towards the bracket number 1. Brackets are the only machined surfaces provided by the manufacturer. This is the bracket number 1. This is the punch mark of the bracket 1 already provided by the manufacturer. So now using the tri-square we will going to draw one line that will bisect both the edges, that is left edge and the right edge of the bracket, and we will get 2 bisecting points. Now punching the points on the left edge and on the right edge. In the same manner, using the tri-square, we will draw one line that will pass through the center point of the bracket. It will bisect the upper edge of the bracket. Now punching that point. Now using the caliper and taking these left and right edges bisecting point as a center, we will draw 2 arcs on the side plate of the longitudinal beam. Now punching that point. Now using the steel rule and aligning the side plate point and upper edge bisecting point of the bracket, we'll draw one line that will cut the lower edge of the side plate at a point. Now punching that point. Now going back to the reference drawing, we have to mark a distance of 260.4 from the last punched point. Using the caliper and steel rule, we are going to mark one arc of 260.4 mm from this punched point on the lower edge of the side plate of the longitudinal beam. After getting this point, using tri-square we will make one line that will cut the upper edge of the side plate. Moving to the drawing, this is the top view of the particular area. This is a side view. The area we are dealing with, this is the cross-sectional view. We have to mark a distance of 201.5 from the previously got point on the top edge over the top plate of the longitudinal beam. So using the caliper, we have to butt a straight gauge against the bracket and again butting the tri-square against the straight gauge. Now using the caliper, taking the starting point of the tri-square as a center, we have to mark a point on the top edge and now punching them. No air gaps should come between the butting surfaces. Okay, this is the pop mark A or C. The same fashion, this is about the bracket number 1. Now moving to bracket number 2, here we have to mark the 2 pop marks, both on left side, on right side. So this is the already available punch mark by the manufacturer. So we are starting the same procedure using the tri-square, marking that bisector line in order to get both the bisector point on the left edge as well as right edge. This is the procedure. Now punching both the points on the edges. In the similar way, using the tri-square, we got the bisector point on the upper edge. Now punching this point. Actually this point we needed for the alignment. Again, using caliper, we are marking an arc over the side plate of the longitudinal beam in order to get a point on the side plate. Now punching that point, we have to project this point over the lower edge of the side plate. For that upper edge point on the bracket we needed, so for the alignment purpose only. So we are projecting that point on the lower edge and then punching it. Now again moving back to drawing. Okay, this is the particular area. We have to mark a distance of 260.4 on the left side as well as right side using the caliper. Okay, so using the steel rule and again using the caliper, we are marking 2 arcs on the lower edges to get the point on the side plate. First on the right side, then again on the left side. Now using the tri-square, we are making the straight lines in order to project these points on the upper edge of the top plate. This is for the left side. Now moving back to drawing, this is the top view, this is the side view of the particular area. Now moving to the cross-sectional view. From here we have to mark a distance of 201.5 on the top plate in the similar fashion that we have done earlier. Now butting the straight gauge against the bracket and again butting the tri-square against that edge of the straight gauge, and using the caliper we are marking an arc of 201.5 on the top plate in order to get a pop mark. So this is pop mark. We are punching for the left side the bracket number 2 and in the similar way on the right side of the bracket number 2. This is the pop mark number F and this is B. Now moving to bracket number 3, again getting those bisector points, punching the points. You must remember this is the only machine surface, that is why we are taking every reference from here only, because we cannot rely on other surfaces. Again punching on the top edge for the alignment purpose. Here for the bracket number 3 we can use the tri-square also for projecting that point, but in order to keep up with the original process we are doing this, so that you should not confused that tri-square can be used here or not. Again punching that mark on the lower edge. Again going back to drawing. In the drawing this distance is not given, but it is the same as the previous cases, 260.4. So we have to mark this distance on the lower edge of the side plate using the caliper. Okay. 5 we have marked an arc on the lower edge. Now using the tri-square we are projecting this mark to upper edge of the side plate, or I can say in the top plate. Now this is a top view, this is a side view of the particular area, this is a cross sectional view. Now again we are going to mark 201.5 point over the top plate, again butting the straight gauge, then tri-square, then using caliper marking an arc of 201.5 on the top plate. We got another pop mark. Now punching this for easy identification, and this is the pop mark. So after getting all the pop marks on the right side, we will move towards the left side. Bracket number 4, 5 and 6. So in the bracket number 4 we will mark the pop marks B or D using the same method. For the bracket number 5 we will going to mark 2 points, that is E on the left side, and using the previous methods, pop mark A on the right side. Now for the bracket number 6 we will going to mark pop mark C or F on the right side. So after marking all the or locating all the pop marks, our next step is the checking the corresponding pop marks distances using trimming edges, whether they are under permissible difference value or not. Here in the drawing we have to check total 6 distances from A to F. So using 2 trimming edges, here we are checking the distance A. This is the distance between AA pop mark that we have already marked between bracket number 1 and bracket number 5. This is the distance B. In the similar way, using the same trimming edge, we are measuring this distance, that is E, and this is F. Now using this another trimming edge, we are checking the distance C. Actually during this entire procedure the most difficult part is only the location of the pop mark, that is how to locate the pop marks. This is the most difficult thing. So this is the last distance D. It is the end of the video. So this is how the trimming procedure for the fabricated bogie frame is being carried out in our GOC facility. Thank you and Dhanyavad.